Thank you very much, Sani. I have 4 minutes to get from this slide to the next slide. Good morning. I've infected my entire presentation with emoji. I've never used emoji before. I'm probably using it wrong, but one of my philosophies is you have to use something incorrectly and poorly before you can learn to use it right. So if anybody is an emoji expert, I apologize in advance. So here we go. There's my first emoji attempt. Who am I? Tim Oxley, as Sani mentioned, that I'm an Australian developer. I've been living in Singapore for the last 3 or 4 years. I grew up on PHP and all that rubbish. Ended up deciding I wanted to do something with my life, so I got rid of PHP. So I shouldn't bash any technology really, but anyway. Moved to JavaScript and started presenting at meetups, ended up becoming okay at what I do. Okay. I now work for a company called NodeSource. So NodeSource is trying to make Node better for enterprises. So Node's going crazy at the moment, and we're building tools to help enterprise use Node better. We launched a product called NSolid about a month ago. It's the first big product that I've been involved in, so I'm kind of proud of it. So I'm just plugging that a little bit. We produce like a runtime for Node that allows you to get like cool introspection capabilities, so you can get like stack traces and CPU profiles out of it, and visualize them in beautiful graphs like that. So on to my talk, modular versus monolith. This is something which some of you may be familiar with me discussing this at length in the past at various times. One of the times in which I discussed this was a 2012, not JSConf, it was JSCamp. JSCamp. It's confusing because I have CampJS and then it was JSCamp. So I spoke about this, but I have changed my mind. So if anybody is familiar with what I said, this will be different. So just a little bit of background. Node has this, compared to a lot of other ecosystems, we've got this culture of extreme modularity. The idea is that you can build an application up out of like lots of little tiny pieces. Each has like a single responsibility, and you're building using like lots of little Lego blocks. And it's not uncommon to see projects using hundreds, if not thousands, of dependencies. Often hundreds, if not thousands, of the same dependency, which is very unfortunate. Hopefully it's resolved in NPM 3. If anything, will actually install eventually. Anyway, so in 2012, I spoke about the idea of building modular applications, and the idea, I feel like maybe I was a little bit immature at the time, so take some of this with a grain of salt. But one of the things which I was advocating was avoiding frameworks because they give you vendor lock-in. It's really difficult, once you're on a framework, it's difficult to move away from a framework because all of your code's locked to that framework. And because it's locked to the framework, you're also in a situation where when the framework dies, so does all of your code. This is a bad thing, and it's something that we should be trying to avoid if we're trying to continue having our code bases live for long periods of time. My main objection to using frameworks is actually, it's more just investment in something which is going to go away quickly. So after every 18 months, I felt like, oh, now I don't know anything about web development anymore. It's a really frustrating thing, a noob every 18 months. So my solution, the solution that I presented was rather than building on top of frameworks, you build things using libraries. Libraries solve all of your problems. If you build something with a library, it'll be reusable. It'll be more robust. You can write documentation in the README for the library. You'll make better code quality because you're solving smaller, simpler problems. You've got less things going on. It's all about sort of keeping things simple, to the point, single responsibility, etc. And not only that, the great thing about it is that it makes it very easy to take something which you've built and open source it. And the way I was treating this was, well, okay, if you can open source it, why not open source everything from the beginning? You know, library first development. The concept was, if you've got something, if you're, you know, we often will pull tools out of NPM and use them in our projects to solve various problems. And if, you know, I sort of saw it as my responsibility, if I feel like I need something, if I'm looking for something and I don't find it, it's my responsibility as an open source developer to, well, I'm going to fill in that gap. If I've been able to fill in 9 out of my 10 gaps, it's my responsibility to fill in the 10th one. And so if by producing libraries, you're producing high quality code overall, and has, you know, got the benefit for the community. You know, the overall quality is better. So wouldn't it make sense to build your entire application as a big set of libraries and start? You know, why not even start with libraries? At the time, I was talking about a project called Component, which was a thing by T.J. Holloway-Juck. Unfortunately, between 2012 and 2015, well, Component died, which was okay though. It's okay. One of the things that I mentioned in the talk was that if Component dies, there's no, you know, there was only a little bit of overhead. So a lot of the things which I made components, I don't know, I had probably 20, 30 components. They're all now NPM modules, so that was nice. But unfortunately, there are some other major issues with building things library first, or even having a heavy focus on constructing libraries out of the pieces which you're using to construct your application. Number one is that there's rabbit holes everywhere. It's very difficult. If you're trying to build libraries to solve all of your problems, you end up just constantly building libraries. I remember there was one day I started out with a particular problem, and 3 days later, I realized I'd built like 4 or 5 libraries, and I hadn't even got all the pieces that I needed to solve the original problem. It's good because all these libraries, these are actually some of my more popular libraries on NPM at the moment, but they weren't solving the problem that I had at the time, which was something actually quite simple. It's very frustrating. And the problem was, you know, if you think of the idea of a library, it's often it's quite simple, and you think, oh yeah, I'll get this done in about 20 minutes. But in reality, libraries take a lot longer. I find that if I'm going to be producing something of a high level of quality, something that's open sourceable, it generally takes me at least 6 to 8 hours. And that's just for, like, for example, if my library just has 1 line of code in it, it's, you know, maybe a few more than that. But if you're working, even for the simplest stuff, it can take this amount of time, because you'll build your thing, you'll realize that the API is not very good when you start writing the README. Like, oh, I can't publish this is embarrassing. It takes too many arguments. So you go and you change your API, which means you need to update your test, which means you need to update the documentation which you just wrote. And you end up with this thing which, because it's supposed to be reusable now, you end up having to take into account all these additional use cases which probably never happen in your application, but because you want this to be, you don't want the next person to use your library to pass it some strange value and the thing breaks, so you want to make it robust. But this is an awful lot of work. And unfortunately, all those qualities that I was discussing before, reusable, more robust, high quality code, all this stuff, it doesn't just come for free magically by building things with libraries. This is an unfortunate thing, and something I didn't really take into account. I sort of assumed that the reason why this stuff's taking so long is because I'm crap. But maybe it wasn't because I was crap, it's just that things just take time. Or maybe I am crap, and maybe I just need to live with that. That's okay. I can live with that. The problem is that if you try to build everything at 100% quality all of the time, you end up investing an awful lot of time over-engineering, because you're building stuff which, like I said, is taking into account cases which you don't need in your application. You're making it more robust than it needs to be. Maybe it doesn't even need documentation because it's like one function and it takes 2 arguments, and a comment above it will be sufficient. So the thing is, most of the time, you're not going to need all of this additional quality that you're injecting. And the worst part is, a lot of the time, I would build stuff and then go to integrate it and then discover I didn't even need the thing in the first place. I could have just done the whole thing with 1 line of code. And this is just such a waste of time. Great for the community, and I think that's probably one of the reasons why NPM has, most of it's the largest package repository ever in the history of humanity, because a lot of people are over-engineering. It's great, benefits the community, but may not necessarily benefit the people who are actually paying you to build the right thing. So, unfortunately, if you're building libraries first, often you'll build the wrong thing. So the solution to this is to constantly be asking yourself, what problem am I trying to solve? Is this the simplest thing which will work? And I would often ask myself that while I was having a shower. I do a lot of thinking in the shower, so I enjoyed. So that's why that emoji's there. Just had to explain that. Often, if it's not the simplest thing, you need to, roll back. I don't know. This is just something which I have in my mind, and I'm almost always, when I'm doing things, the answer is no. It sucks, but that's okay. We try to get better. There's a quote, don't know where it came from, which reads, "We've all had projects in which we spent 80% of the time working on a small piece which we found interesting, and 20% of the time building the other 80% of the program." And this is something this is, again, the reason why I like to build those modules, is I'm like, oh yeah, I'm going to solve this problem really well. And I find that interesting, the idea of taking something and doing a good job of it, understanding the whole thing. But yeah, is that the simplest thing that will work? Probably not. And the way I get around, another way that I trick myself, a question that I ask myself to figure out, is this the right decision? Should I build this? Is if I ask myself, is this going to be fun? If I think something's going to be fun, I probably shouldn't be building it, because I'm building it for me, not for the product. This is a horrible reality. I hate this. But yeah, a lot of the time, if you're building something that's fun, you should probably second guess whether you're building it for you or actually to solve the problem. It's a little sucks. Maybe there's a better way, but anyway. Overall, the point here is that avoid premature modularization, because you might end up putting the wrong thing into your program, because it's difficult to know up front all of the things that you're going to need. So tend to build things top down. I've put a saxophone in here because I had this sort of idea of, this image in my head of starting a band. I've always wanted to start a band. I've been in bands, but they were never any good. But I had this vision of like starting a band and like writing this excellent lead part, and then just jumping on the first instrument that I saw was like a saxophone, but then later realizing, oh well, hang on, we're in a metal band. What the hell am I doing with a saxophone in there? So if we're going to avoid premature modularization, what are our other options? Our other options are these things. Before, whenever I needed to modularize something, I would just instantly go straight for external package, because this seemed, if you look at a lot of the prolific authors of stuff, this seems to be the way that they work, but I'm not sure whether this is actually a good way to work in your everyday work. So you've got all these other options which are much simpler, which come with far lower overheads, which you can use before you end up moving something out. So basically, what I'm trying to say is I don't even mind having a whole bunch of stuff just in one function. That's fine, as long as it's not complicated. But if that gets complicated, if it's too much to hold in your head, then you can break it out to a file, folder, or an internal package. All these things which have lower overheads before you get to external package. Next point is assume that your first attempt will be bad. So this is another thing. If you're building things which are open source and your first attempt is bad, well, one, you've now got other people using your bad first attempt. But two, you've gone and invested all this time in adding all that documentation, all those tests into something which may or may not be the best solution. Like tests are a really good way of making sure that your code doesn't change. And so maybe it's important to prototype, I guess is what I'm trying to say here. It's not always clear how to best slice up the logic for your application, and you're probably going to make some bad decisions up front due to incomplete or missing information. So not only that, you'll end up with, you'll slice things up in a way which doesn't make sense next week. It might have made sense for the changes now, but it doesn't make sense later. And especially if you're building things library first, like I was, the longer you leave integration with your application, the greater the chance that you're going to discover that the thing that you're building doesn't make any sense. And one of the times when I realized how bad my first attempts were was at Code Retreat. So I have very fond memories of doing code retreats. And we did one for DevFest.Asia. Who actually came along to that? A couple of people? One? Okay, a couple of people. There we go. So that's good. More people should go. Next time there's one, make sure you go to this because it was really eye-opening for me. When I went to Code Retreat a few years ago, between 2012 and 2015, I realized, so you've got, the idea of a code retreat is that you've got 45 minutes to try and implement a very simple algorithm using test-driven development. And after the 45 minutes, you delete your code and pause briefly for reflection, and then you find a new partner. Oh, sorry, you're doing it all in pair programming. You find a new partner, and then you repeat. And so over the course of the day, you solve the same problem over and over again, maybe 4 or 5 times. And the general experience seems to be that everybody starts out building like classes and all this just boilerplate rubbish. You know, you'll see things with accesses and pretty much everything except for implementing the 4 properties of this algorithm. And I remember there was one group who said, oh, yeah, no, we're nearly done, we just need to implement the algorithm now. And I was like, that's where you should have started. And so they were building all these pieces, and I was building all these pieces, it's not just everybody else. And then it made me realize, it scared the shit out of me because I was like, everything that I build is usually just on the first attempt. And I'm probably injecting all this additional complexity into my applications that I never go back and delete and revisit. So this is eye-opening. So I guess the suggestion here is that if you're going to be, don't get precious about your code. Often we try to make our code live for as long as possible. So, you know, we make it extensible, we make it robust, all this kind of stuff. But perhaps a better solution is to start by, well, first validate that this thing even needs to exist, validate that it's a good solution to the problem, and if it's not, revisit it, delete your code, start again. I guess, yeah, point is, don't be afraid to delete your code and start over. And there was a good anecdote, from me. I remember I spent days working on this feature. I was late. I couldn't get this thing done. I'd made it really hard, and I was really stressed about it. And I'd written some tests, and in the teardown of in the setup of the tests, I wiped the working folder, and then keep working. Keep going with the tests. What I didn't realize is I'd accidentally put too many dots in which folder to delete, and it deleted my project folder. And because I was stressed, I hadn't been obeying best practices, and I hadn't committed for maybe 2 or 3 days. I deleted my Git folder, of course. So it was just gone. It was just nothing. Sorry, I had been committing, but I hadn't been pushing because I didn't want my peers to see my crappy attempts at doing something complicated. Anyway, deadline was looming. I think I had to demo this thing at 11 p.m. And I managed to pull it together in 4 or 5 hours. And I was like, well, what the hell have I been doing? Like, why did I spend 2 or 3 days? And what had happened is that over the 2 or 3 days, I'd realized I'd got a proper understanding of the problem, and I was more fighting my crappy implementation rather than actually solving the problem. So why didn't I delete my code earlier is the question. So over-engineering, the adding of unnecessary complexity. This is something that we all do, and something we should try to avoid. Picking emojis for these slides is very difficult. That may look like a fat man that's fallen over, but it's a baby. And I thought that this was a good example of over-engineering. At least in Australia, we often have people often use they make a baby to save a relationship, and I thought that was a good example of over-engineering. Don't do that. Over-engineering. It's probably a simpler solution. Just talk to each other. Point is, complexity kills projects. This is like the leading source of project death is complexity, and you want to avoid it. But because complexity increases the likelihood that you're going to end up with bugs, security problems. It stops you from being able to add additional features. It's the shittest. So we want to avoid complexity on any level. Over-engineering adds complexity. And I found that, at least in my circles, that over-engineering is far more common than under-engineering. If you've been reading books about programming, a lot of the content that you read is about preventing under-engineering. They tell you how to break things up and single responsibility principle, all this kind of stuff. But there's not a huge amount of advice on how do you prevent people from taking that too far, because often, the simple solution for today's problem is not a simple solution for tomorrow's problem. If you're doing over-engineering, this is going to be far more costly than under-engineering. This is because the wrong structure is going to be more costly to change than having no structure at all. This is something which I've found quite often. When I work on old rubbish applications, I find myself able to be a lot more productive as long as they have tests, because if people are just writing big, long, dirty methods and it's disgusting, you hate yourself by contributing to this mess. But I find myself weirdly productive than if I'd gone in and tried to make things good, make things structured, make things awesome. So structure can be easily extracted from no structure, but incorrect structure, you first need to reverse it before you can change it. So the way that I've been working these days is trying to make the least amount of decisions possible and just let the code kind of be a little bit crap. It's okay, because you're probably not going to make a good decision about how to make it less crap now. Make it later. Defer decisions. If you're the thinking with that, it's like if somebody hands you a grub, you don't know whether you're going to get a moth or a butterfly. So you don't know whether do I keep this or do I put it outside? Defer making important decisions for as long as you can, because you will always have more information later, and this will help you make better decisions. So every decision that you make now is going to be a worse decision than a decision that you make later. So try not to make decisions. Just leave it. Leave it. And the best way you can leave it is by this is pretty much the exact same point. Draw in pencil before you draw in ink. Make sure that you haven't, not too much structure. This particular point actually, something that I discovered before. I wanted to be a musician, and I was working with a guy, and he was like, Tim, you never finish a song. You end up just working on a little loop. I was like, yeah, it's a good loop. He's like, but that's not a song. We're trying to sell songs. And I'd be working for like hours just trying to get make sure the snare was compressed correctly, had the right EQ, and because once I get the good loop, then I can make the song. But what ends up happening is you get so focused on this loop that you have no perspective of the big picture of, well, what does this even look like in the context of a song? And now I have a whole library of just loops. They're not songs, and there's nothing I can do about them because I can't think about them in the context of a song. So the idea here is that, well, this guy just said, Tim, you're not allowed to use a compressor, not allowed to use EQ until you at least have a song structure in place. And instantly, as soon as I had the song structure in place, I was able to put together songs. They weren't good songs, but they were actual songs. They were better than loops. And then later, I could come back and fix the loops and change stuff. And what ended up happening was, don't worry about if the thing that you put into your code now, it doesn't have to be there forever. You can delete it. It's just like a starting point. I would just write the crappiest baseline I possibly could just to get me a starting point, something to build on. And you should do the same thing in your code. Just get something to start with that you can build on top of. So when you're building code, you're often trying to organize things by adding abstractions. And the abstractions will they'll decrease the local complexity, so they solve the small problem while increasing the global complexity. So a good example is if there's a project, an open source project, I guess I won't mention it, but there's an open source project that I was working with recently which had one function per file. And it had a hell of a lot of functions. And this was very difficult to actually understand, to actually figure out what was going on in the program. You have to open file, and then you have a file which is just, all it's doing is requiring some other file. And it's just you're following this horrible, endless chain of complexity. And it's very frustrating because it's the whole concept of can't see the forest for the trees. So every time you add an abstraction, it adds to the global complexity. So just be aware of that and try to reduce complexity everywhere. Because we often find ourselves building the wrong thing for the right reason. So we can justify building our abstract function factory, but it makes sense. It'll make things easier in the long run to have this thing, but perhaps a simpler solution would have worked. And there's there's probably people who know what slide I'm going to bring up next. XKCD comic. And this is what engineers do all the time. The alt text here is, I find that when someone's taking time to do something right in the present, they're a perfectionist with no ability to prioritize. Whereas when someone took time to do something right in the past, they're a master artisan of great foresight. But I think this is the kind of thing that we as engineers do all the time. And it's horrible. I mean, we should stop this. So the point is, build the simplest thing that works. And sometimes a good rule that I find for trying to make sure that I build the simplest thing that works is flat is better than nested. And this is one of my favorite mantras because you're able to use this thing to guide design decisions all the way from statement level all the way up to package level. So, for example, at the statement level, you should try to avoid complex chains of if-else logic. That sucks. At function level, you shouldn't have nested callbacks. Class level, you shouldn't have multiple levels of inheritance. These are just examples. But the idea is that whenever you have a choice between a nested structure and a flat structure, you should probably always pick the flat structure. So, because the simplest thing is probably flat. So back to what this talks about, modular versus monolith. Being somebody, I've built things purely monolith and purely modular. The projects that I built purely modular are still in development. So I think that the sweet spot's probably somewhere in the middle. I don't know if that's a good name, but but maybe. Point is, we should try to avoid premature modularization. Stop trying to architect things too much in advance. Just simplest thing that'll work. And often the simplest thing that will work is to build a monolith. This is probably a statement which in 2012 I wouldn't have thought I would ever be making, but I truly believe in this now. I'm converted, and the reason why is because yeah, we have all these other options to use before we get to breaking things out into external packages. So, and the other thing is a really nice thing I think about what Facebook and Google, a bunch of other big companies, when big companies do open source, they don't just open source everything that they're doing that might solve a problem. They solve the problem internally first, make sure that they get it right, and then they open source it. And I was thinking, like, if you're selling somebody a toilet, you want to make sure that it works before you give it to them, otherwise they're going to be very unhappy. Because one of the problems with NPM at the moment is that there's an awful lot of abandonware. So these are things which people have built to solve, which they thought they were going to use to solve such and such a problem, but it turns out that you know, they didn't need it, or it wasn't the right fit, or whatever. There's an awful lot of abandonware on NPM, and this sucks. And I own a lot of abandonware. It's because it's very hard to maintain or even make good decisions about the direction of a package that you yourself don't use. I'm very happy for other people to use my packages, but if I don't use it, I'm not in a very good position to be making good decisions about it. So, and I haven't got this in the slide, but there's a good community-driven solution for this, which is, it's called open source. So if you go to openopensource.com.net, there's a manifesto there, and the basic idea is that, especially in the situation that you are no longer maintaining something, or you're no longer interested in maintaining something, but even if you are, a good policy to adopt is adopting new anybody who's like interested in being, anybody who makes a significant contribution to the project becomes a contributor. And then that's additional resources that your project now has to field requests, publish new versions, etc. So perhaps after the point that when you're no longer interested in whatever it is that you're building, somebody else can pick it up and run with it. And this works. There's this amazing thing which happens when you give somebody commit rights to your project. It might be like sort of a scary thing. You think, oh, well, they're going to delete it and replace it with CoffeeScript. But in reality, this doesn't happen. When you give people responsibility, they generally take that seriously. And you actually see an increase in activity because they feel like they need to live up to this responsibility that you've given them. So I found that I haven't done this a huge amount on my projects, but I know that it's worked very well for a lot of other people. And in fact, with the author of Express's departure from the JS community, this is the open source model is basically what's happened to all of his packages. Anybody who made significant contributions to those packages are now maintainers. So that's nice. But the point is, we're talking about over-engineering. Let's do less of it. Build the simplest thing that works. Oh, yeah, saxophone. And avoid unnecessary complexity. So, the bowl. So I was thinking here, I'm justifying my emoji use here. When you're at home and nobody's there, do you even need to use a bowl? Just eat it out of the can. Do you even need to heat it up? Just open that lid, just eat it. Avoid unnecessary complexity. Thank you.
Thank you, Tim. Thank you so much.
Questions?
Questions? Okay, maybe a couple.
I just want to come in and ask about something about over-engineering and under-engineering, because I have found that the over-engineering usually the consequence of the previous under-engineering. So it seems that people swim between the two ends and they never find the moderate middle. For example, I have seen one 16,000 lines of in one JavaScript our manual writing. So that's why that's the result of people try to flag all the things, but apparently it's a fail. So I think that's a point and the question. Maybe you can find some middle point that you have. No,
that is really hard. The point is that balancing this stuff is hard. But I guess the thing is that a lot of over-engineering does come from being, it's reactionary. So you get burnt by something in the past, like frameworks, and then you're like, never again, rally against them, destroy every single framework there is. But maybe that's an overreaction. Maybe the best solution, I don't know what the best solution is. It's hard, balance.
Right, one last question.
Here.
Two. I'll be quick.
Yeah. First of all, awesome talk. A lot of great insights. Couldn't agree more. And I think that another thing that might worth referring to or mentioning is software longevity, because a lot of times we just write something and we hope that at some point in the future it will be useful for someone. But in reality, if we write software for a living, if we get paid for it, even at the best case scenario, it's unlikely that our code will outlive more than 5 years.
Yeah, it shouldn't. And I guess there's probably a deleted slide in there about this. But one of the things which I find best is just to, don't design your code for extensibility. Design your code so that it can be easily deleted. So instead of trying to force your code to live forever, force your code to be deleted quickly. I think that's a better policy.
I remember there's a saying that one of the virtues of programmer is being lazy. Lazy, arrogant, selfish, I think that. So do you think one of your problem is that you work too hard?
Well, I think sometimes we think we're being lazy because we'll spend, I don't want to do find and replace in these files. I'm going to write a tool. This is me being lazy. But it turns out a lot of the time you'll spend an hour or 5 hours or 2 days saving yourself 5 minutes down the road with the idea that, okay, I'm being lazy. I think we do too much, and focusing on just the task at hand, I think, is the important thing.
All right, thank you, Tim Oxley.